This is our hovercraft design, built for efficient lift, strong propulsion, and stable control. Introducing the high-performance hovercraft base and skirt assembly. Designed for maximum structural integrity, featuring reinforced internal supports and precision-aligned bolt patterns for secure, airtight fit. This configuration ensures optimal airflow distribution and consistent lift across the entire perimeter. Finalizing the build with our integrated articulating D-ring, providing a robust, high-load tethering point for any mission.
This hovercraft is powered by a V8 internal combustion engine. It includes components like pistons, connecting rods, and the engine block. The pistons move within the cylinders, transferring force through the connecting rods to the crankshaft. The crankshaft converts this motion into rotational power. This power is used to drive the hovercraft's thrust and lift systems efficiently.
The spark plug ignites the air-fuel mixture inside the engine cylinder, generating combustion to power the piston and produce mechanical output.
The transmission is a bridge between the engine and the propellers, taking the V8's raw torque and splitting it between the lift fan and the rear thrust propellers in a controlled manner. Using a specialized gear set, it turns high engine torque into high RPMs, greatly improving the efficiency of the hovercraft to keep you hovering and moving forward.
For our automatic transmission, to switch gears we are using a gear pump to push the transmission fluid. A gear pump is a type of positive displacement pump that moves fluid by trapping a fixed volume between rotating, meshing gears and transferring it to the outlet. These compact self-priming pumps produce a smooth pulse-free flow, making them ideal for high-pressure applications like hydraulic power units, lubricants, and high-viscosity chemicals.
Here is the propulsion system, showing the propeller assembly mated to the drivetrain. The rudders are controlled via a mechanical linkage system, driven directly by a pneumatic linear actuator. As shown in the exploded view, the drivetrain utilizes two 90-degree bevel gear transfers to power the fan. To ensure longevity, the fan shroud includes rubber dampening inserts to mitigate vibrational wear. The linear actuator is supported by dual air canisters for bidirectional steering, with the entire unit securely bolted for structural rigidity. This compact design provides the necessary thrust and maneuverability for the hovercraft.
The drivetrain architecture is engineered to translate high RPM input into a stable thrust through the bottom of the hovercraft. Central to this assembly are the control arms, which disperse forces generated by the lift fans into the supports in the fan covers and throughout the body. Power distribution is facilitated by a series of ball bearings, allowing the system to effectively manage and stabilize the massive thrust generated by the 8-blade fan array, allowing continuous lift of the vehicle. These gauges allow you to gain a quick overview as to how the main lift fan is operating. It allows you to view the RPM, the thrust it's producing, and the temperature of its internals to make sure everything is running smoothly.
The high-performance user area of the hovercraft includes the cabin, dashboard, seat, and other accessories. The dashboard is designed to be user-friendly and effective. Moving gauges provide real-time feedback for the operator. Front headlights improve visibility in low-light conditions. The seat is centered and rotates for better control and comfort.
And that concludes our hovercraft design. Thanks for watching.